Hey everybody, Justin here. Thank you for checking out this video. And in this video, I'm looking at what I would call question 4 on the Galton boards. And again, these are Galton boards from, you can check out Four Pines Publishing. They have a couple different models, couple different styles. They're really high quality Galton boards, pretty cool to play with. So I'm looking at the question of, just kind of like, if you're new to statistics, you might be wondering what this is right here, okay? And this is called the standard deviation. You can see the equation there. So I'm going to explain what the standard deviation is. So this is just kind of intuitively, if we look at this cascade of ball bearings, I'll reset it. But if we look at that cascade, so I'll reset it right now, and they're coming down, on average, they'll be right about here, okay? So you can see, on average, most of the balls in this situation end up here, end up in this range, okay? But there is like a spread, right? They can be way over here, they can be way over here. If we had this Galton board extended, there might be some like way over here where my finger is, or way over here. So the not just the estimate, like an average of where things are, but a measure of spread tells you a lot. So for example, with this theoretical normal distribution, this curve here, roughly between one standard deviation plus or minus, you would get about 68% of the data. In other words, 68% of the ball bearings are in this range right here. And you can see that with these green numbers down here. You got 34% between the average and one standard deviation, and from the average up one standard deviation. So this range here has about 68% of the balls there, the ball bearings. If you go out 2 standard deviations where the blue is, you're looking at, I think, like 95%. And if you go out 3 standard deviations, you're looking at, 99% of the data would be within those bounds. So, if you've seen a study that says, so many people favor a candidate, say 73% or something like that, and then you have that little, plus or minus 5%. That plus or minus 5%, there's a little more to it, but it's essentially the standard deviation. It's essentially a measure of spread, and that's what this equation is essentially doing up here. Like I said, there's a little bit more to it than that for those poles and standard errors and stuff, but the standard deviation is a component of that. So if we look at the equation itself, the x sub i's are the individual observations, and the x bar, the x with a little bar on top of it, that is the average of those observations. So you're taking the distances an observation is from its average. Sorry, a bus going by right now. You're taking the distance an observation is from its average, and you're squaring it. You're adding all those up, and then you're dividing by n minus 1. So what that's doing is that's basically taking an average squared distance, or think of it like as an average distance. And then what you're doing is taking a square root, because if we square something, like say we're measuring weights, if we sum up the squared distances and divide by n minus 1, our result will be in pounds squared or kilos squared. So we take a square root to get it back on the original scale. Another technical point is this n minus 1. Kind of some people like, why is that there? N minus 1, why isn't it n? Well, that's kind of a more technical math to make it an unbiased estimator of a population standard deviation. But really, we can think about it as if you have a lot of data and divide by n, or n minus 1, it's basically the same thing. I wouldn't sweat the details that much. Like, if I do 1 divided by 10,000, that's about the same as 1 divided by 9,999. So it's just a way to make it what's called an unbiased estimator. So for any data set you have, you can calculate an average or a total, and you can also calculate a standard deviation, a measure of the spread of the data. And there are other measures of spread. You have a variance, you have interquartile range, a lot of different things. But that's just one of the things, probably the most common thing to do. And this equation up here is the equation of a normal distribution with center or average mu, that little Greek M. It looks like an M with like a longer leg, and there we go. And then, sorry, just try to get this focus here a little bit. There we go. And then you see a sigma in there too. That's like a Greek S. And what the standard deviation is that's an estimate of that population standard deviation, that sigma. So that equation right there, that describes this normal curve right here. Okay. So anyways, I just wanted to explain what the standard deviation is. And again, intuitively, it's just a measure of spread of the data. And mathematically, you're taking the square root of the average of the squared distances. So with any data set, you have like a center, or like say like an average, and then you have a measure of spread. And if the spread is real small, it means most of the stuff is clustered around here, around the average. If the spread is large, the standard deviation is large, your data is more spread out. Okay, so I just wanted to explain those concepts, and I appreciate you watching, and I'll see you next video. Bye-bye.